point is that if you have designed any running time for any program problem, if you have designed an algorithm whose recursive equation is like this, suppose like this: t of alpha 1 n plus t of alpha 2 n plus some linear, then what will be the solution for this? So here you will see, if alpha 1 plus alpha 2 that is less than 1, then please remember Tn will be linear. Clear? So just as in the median finding algorithm, you check that alpha 1 and alpha 2, if you add this is less than equal to 1, and if it is the fn is big O of n, this was the function fn, then Tn will be, total time complexity of this will be this. Very important point. Please remember. That means you try to design in such a way that the recursion equation, if possible, not it is not always possible. If possible, then that alpha 1 plus alpha 2 should be less than equal to 1. But if alpha 1 plus alpha 2 equal to 1, if it becomes just 1, then what happens? Then Tn becomes n log n. Just like in say Tn equals Tn by 2 plus Tn by 2 plus big O of n. So that is equal to 2 Tn by 2, you know, plus big O of n. So this is merge sort. For merge sort, this is big O of n log n. And what is the alpha 1 here? Here alpha 1 is half, you check it, and alpha 2 is also half. So alpha 1 plus alpha 2 equal to 1. So if it is equal to 1, then it is big O of n log n. Otherwise this. So when alpha 1 plus alpha 2 becomes less than 1, in the case when you are removing a part of the suppose this is a feasible solution, these are the domain, means these are the points or whatever it may be, that depends on the problem, these are the numbers. Now if you are sure that I have no solution in this part I have no solution, just throw away. Okay, or you can say that means this is prune, you prune that, just like binary search, you prune that portion where solution will not be available. So here also we are doing that thing in median finding algorithm, that you see, if I know that the rank of the p median or median is that is greater than n by 2, then I am searching the lower part, lesser part. If it is greater than, then I am if the rank of is less than n by 2, then I am searching the higher part. If it is greater than n by 2, then I am searching it in the lesser part. That means I am throwing the other part. So always try to, I am saying this is the tricks. This is not for the semester, but I am saying for your future works. You try to design the algorithm so that if you are sure that within this part I have no solution, means there is a property of the problem that I will not get the solution in this zone, I will throw out. So if you can throw out a fraction of the total numbers, suppose n elements are there, so I am throwing out n by 10 elements, 1/10 elements, then also the time complexity will be improved. Clear? So that is the case for in the last algorithm. Now we will start today another algorithm, interesting, closest pair problem. What do you mean by closest pair problem? So I have been given n points. I have been given n points in d dimension. So here actually since you are the undergraduate course, so it is so I am not going to for d dimension, so that is out of syllabus here. So here d is equal to, I am saying d is equal to 2. I am taking d is equal to 2. That means all the are lying on the plane. Fine, these are the points. Now your ask is to find out two points whose mutual distance is smallest, which are the closest. For example, here you see in this figure that this P and Q, they are closest. Their distance is smallest. Okay, but these distances, or say these distances, all these distances are larger than this PQ distance. So I have to find out this. So how can I find out? So this is the fundamental problem. It has many applications. You can search yourself. So if now see what will be the easiest solution. Easiest means anybody can design. I'll compute the distance between all possible pairs. So how many possible pairs are there?
Sir, n square.
NC2 means n square.
NC2, sir.
NC2. So if NC2s are there, that means this is of order of n square. Okay. So and I need to compute the distance between them, and I will compute the minimum one. Clear? So this is big O of n square time. Here d is 2. In our case, d is 2. So this is d of n square time. Now, element uniqueness, I have not said till now. Okay. Means n log n is the lower bound. Element uniqueness problem may be discussed later. So here you see we will use, actually it can be reduced to n log n, okay, using divide and conquer problem. So we are actually studying the divide and conquer problem, that two n bit numbers matrix. Please remember, I have told you to read the similar type of problem that is two n bit multiplications, which is that is called matrix multiplication, Strassens. Please read it. It is in the syllabus. I have not described. It is, you will get in so many books. I have just told how to divide. There will be 4 blocks in a matrix of n by 2, order by n by 2, and how to do that. Please check it. So similarly, the last one also, median finding, was also divide and conquer. So this is another divide and conquer problem, that how to find out the closest pair problem, means the closest pair of n points lying on a plane. So if it is one dimensional, so how one dimensional problem can be solved? Means if the points are on a line. Suppose this is the points. These points are lying on a line. You check it. Each point has, all the points have same y coordinate. So that means, that's why this is one dimensional. Means y coordinate doesn't differ, only x coordinate differ. So in 1D case, all the points are in L log n, a line. So how can I solve this problem in L log n? I will sort the numbers. I will sort all the numbers. Fine. But please remember, sorting does not helps in higher dimension. Okay, 2 dimensional, because they have x and y coordinate. Here I am sorting just on x coordinates. Clear? Now what I will do, we will try to solve means using divide and conquer. So one dimensional problem, divide and conquer for one day. So divide the points. You see, this is one part, and this is another part. How do I divide? I am dividing this into 2 sets, S1 and S2, by some x coordinate, so that P is less than Q for all P belongs to S1 and Q is all belongs to S2. Okay. Actually, you just find out the median of these points. Fine. You find out the median. How much time it takes to find out the median of this set of numbers? You know?
Sir, O n log n.
Big O. No. Big O in earlier class. Linear
Oh,
time.
yes.
No?
Yes,
Don't
yes.
forget. Okay. Now, what you have to do, I am saying this set as S1. Check it. Which lies at the left. And I am saying this set as the S2. Now, among these numbers, there will be 2 closest pair, 2 points means closest. So say P1, P2. Clear? These 2 are closest. Similarly, this here, Q1, Q2 is closest. Clear? So I have computed recursively the closest pair in this partition S1. Similarly, in this partition S2. Now, which can be the closest? If I merge the solution, I either means I shall compute what is the minimum distance between P1 P2 and Q1 Q2. So if delta be the smallest separation, so what is the delta? Delta is the minimum of this this distance and this distance. So here in this partition S1, I am getting delta 1, and in this I am getting delta 2. This is delta 2 and this is delta 1. So in entire set I will get minimum of these two, or what it can be, means I am asking you. So I have the solution for the left part, I have the solution for the right part. So how can I find out the solution for both the parts, means if I merge the solution together?
Minimum.
Minimum of these two.
Yes, sir.
Or is it not possible that you see uh, there exists one point here in this partition and one point in this partition, and I have not, you see, while solving the problem for the left part and right part, they are independent, totally independent. I have not considered any point from S1 and another point from S2. So if, for example, this distance also I should compare, means it may be the case that there is a point like this and there is a point like this, and this distance is minimum. Means, are you getting?
Yes, sir.
So I have to take care of that fact also. So how can I do that? It is easy, that I will take the rightmost point in S1. Which is the rightmost point? This one. I will take the leftmost point in the S2. This one. And I will compute this distance also. Clear? Say let it be delta 3. So what will be the case? The minimum solution will be either this one or this one or this thing. So which one is minimum? That will be the solution for entire points. Is it clear? Now,
Yes, sir.
so how much time does it take to compute which one is the smaller?
Sorry. Uh,
Here you see this is delta 3, means this is delta 2. So I have to compute minimum of delta 1, delta 2, and this means this delta 3. So this is the problem. So if S1 is closest pair, if S is 1, only 1 point, no closest pair, undefined. Okay, if S is 2, then P2 minus P2. Otherwise, do the following steps. What should I do? I will first find out the median of the points, then divide S into S1 and S2 at M. Then closest pair I will solve. That value will be delta 1 for the left part S1, delta 2 for S2 right part, and delta 1 2 that I was telling that means the delta 3 means actually this distance delta 1 2. 1 to 2. So delta 1 2 is the minimum distance across the cut. Across the cut means this is the cut median. So what should I return? I should return this. What will be the recursion equation? Tn equal to 2 Tn by 2 plus big O of n. Okay. This part, see this part you understand. If Tn is the running time complexity for the entire problem, then Tn by 2 will be for the half of the points in S1 and for the half of the points in the S2. So Tn by 2 plus Tn by 2, 2 Tn by 2. And now which corresponds to this big O of n? Can you tell me?
Sir, Does division have closest pair type?
I'm not, your mic is creating problem. Please tell me.
Sir, sir, the division part is taking n, O of n.
Yeah, division, median finding, right?
Yes.
This part is median finding. Yeah. And computing, you see, whenever I'm computing, that is constant time. So big O n plus constant. So that is big O of. So what will be the solution? Big O of n log n. Clear? So this is for now for one dimensional. Now for 2D. And thanks to Professor Subhash Suri. Okay. So for his slide, I am sharing his slide. Now 2D closest pair. Anyway, so 2D closest pair is means there are a set of points lying on a plane. So no, it is not the case that all the points lie on a line. Now how to solve this problem in 2D case? So we partition S into S1 and S2 by a vertical line L defined by the median x coordinates in X. See, each point has X coordinate and Y coordinate. So we'll take the X coordinates and find out the median of all those X coordinate. Fine. And then I will partition the points into two parts. Okay. This is S1 that lie to the left of this line. Okay. Just this is the line L. You check it. And this is the point set S2 that lie at the right side. And this one will go through some median. Okay. Now what we will do? We will compute recursively the closest pair of the two sides, delta 1 and delta 2. So let it be delta 1 here, and this is the delta 2. Fine. Now what we have to do? I have to compute the minimum of this one, or the distance which becomes the minimum within this. Say, suppose now I am saying that delta is the, okay, here it has been written, check it. Delta is minimum of delta 1 and delta 2. Delta is minimum of delta 1 and delta 2. So what we will take? I will take a narrow strips delta and delta, and I will compute the distance among the points from this to this. You see, if I have obtained the solution, means delta 1 in the left side and delta 2 is the left at the right side, and suppose among these two one of them is minimum, and that I am denoting by delta. Okay, suppose delta 1 is the minimum, so this delta is minimum of delta 1 and delta 2, that means delta 1. Delta is delta 1. Now tell me, do you need to compute the distance between this and this? Will it help you? Tell me. Hello? Hello? I can't. Hello?
Yes, sir.
No, I am asking that should I compute the distance between all the pairs, that one from here and one from there?
So,
I think you got the point. Sujato? Hello?
Yes, sir.
Okay. No, I do not know whose mic is it.
It's on my mic, sir. It's on my mic, sir.
Okay, it's creating a noise. So here you see, I should not compute. See, suppose this is a 5 and this is 7, and this unit, you see, this is the 5, 5, because I am taking the minimum of this. Now tell me, should I compute the compare the 2 points, which is one of which is here and one of which is here? After computing delta 1 and delta 2, should I compare the 2 points, one from this side, one from this side, which are far away? No, I should take the points which will lie within this zone. Within this zone, you see. Why? Because you see, if one point is here and one point is here, then their distance is less than equal to delta. But if you take one point here, just here, okay, and you are taking So you are if you are taking this as one point and this is the another point. So what will be the distance? This will be greater than delta. I know already that I have obtained for the left side 5 unit. So why should I compute the distance between 2 points which are already greater than 5? I will not get the closest pair. So to get the closest pair, also I should consider only the points which lie within these strips. See, please, there are three possibilities. Either delta 1 is the minimum, or delta 2 is the minimum, or the distance between 2 points, one of which lie at S1 and one of which lie at S2 may be minimum. But in the third case, the one of which lie at S1 and another one lie at the S2, those 2 points should come only within this strip. Because if you take any 2 points outside, any points outside these strips, and another point inside, or maybe means this side, then their distance is greater than minimum distance of delta 1 and delta 2. Is it clear now? Yes or no? You just tell me. I'm not getting again sound. Anyway, so I assume it is clear. Now, how much time it will take? How much time it will take to find out the closest pair within this strip? If suppose half of the points, okay, you for books I'm saying you can see this problem from the algorithm design by Klinsbergs and Ebertardos, or maybe in some other book also, but I am just saying. Now, uh, in worst case, you may think that if uh, see, there are two strips, P1 and P2. P1 is the set of points lying within the left part, this part, this part, and this part is P2. Clear? P1, P2. Now, how much time will be needed to compute the distance between P1 and P2? In worst case, all the points, see, in worst case, in all the points, or half of the points, means say n by 2 points may lie within P1 and n by 2 point may lie within P2. So to compute the distance between P1 and P2, you need n square by 4, n by 2 into n by 2, n square by 4 comparisons. These many distances you need to compute. That means I am saying that here you may need to compute the distance between these these all pairs. Similarly, these one. In this way, if you are computing the distance between the points that lie within these strips, one from this side and one from this side. Now, in worst case, it may happen that half of the points lie within this, and half of the point lies within this. Then n square. And now, what was your objective? See, please remember always our objective is to compute the minimum distance within big O of n log n time. So that means Tn is 2Tn by 2, left side, right side, plus some big O of n should be there. But here you are saying that if n by 2 points are here, n by 2 points are here, then n square by 4 distance needs to be computed. So it cannot be big O of n. So this will not help us. So how can I do something? Means does there exist some property of the points so that instead of big O of n square it will be big O of n? Yes, there exists. How? See, a special case check. Suppose in the left side of the point, means this is the left, you see this side, both side. So this is the delta, you know already. This is the delta. Now suppose there exists a point here, and I know that delta is what? Minimum of delta 1 comma delta 2, right? Now you consider a window of size. You consider a window of size delta by 2 delta. Delta by 2 delta. You see, this is the window. You check this window, rectangular window. Its size is delta by 2 delta. So that means if it is here, I know its y coordinate, x comma y coordinate of p is known. So I am just drawing a vertical, sorry, horizontal line passing through it, y coordinate. Okay, and here from this you take another point here, just delta above, and here delta below, delta below, delta below, above. So I will get this rectangle. I am saying this rectangle I will get. Now, is it possible that the distance, or see, I will compute the distance between this point and the points lying within this R, within this zone. You see, I am sure the distance between this point and this point will be greater this point and this point. Here, this and this one, I am saying that that will be greater than, that will be greater than delta. That will be greater than delta. Why? Because the vertical height of this window from this point is delta, just this delta. So I should not consider any point beyond this rectangular region. Fine. So when I am taking this point, please remember, when I am taking this point, left side point P, this, then I am considering this window. Clear? I will consider only the points that lie within this rectangular window. This. Now, how many points can lie within R if each pair is at least delta apart? See, I know in the right side the minimum distance. See, all these rectangle, this region. Please check it. These rectangular region rise at the right side of this line L. And I know the minimum distance between any two pair is the either delta 1 or delta 2, whatever it may be the case. But I am sure that either delta 1 or delta 2 is there. So in this case, I will get at most, you see, at most 6 points. This one, this one, this one, this one, this one, and this one. So that the distance between the, you check it, is less than equal to delta. If anybody thinks, suppose you are thinking that there may be more points, say like this. Suppose I am drawing this. This. So this is delta. All these sides are lengths of delta. Fine. Now, if here in this case, see here, I am again further subdividing it. This delta by 2 by delta 2. This is delta by 2, delta by 2. Okay, delta by 2, delta by 2, delta by 2, like this. So what is the distance between of this diagonal? This diagonal will be delta by 2 square plus delta by 2 square root. That is equal to delta by 2 square root 2. Means delta by square root 2. This. Now, this value is less than delta. Check it. This value is less than delta. So you see, within this smaller rectangle, there can exist only one point, not 2 points. If there exist 2 points, you see, then their distance will be less than delta. But I know at the right side and then the left side, the means I am taking this width is the minimum, na? Closest pair is this. So at most one pair of points will be there means only one point will be there. So similarly, 1 1 1. So 1 1 1 1 4. Similarly, in this case also 4. But you see, if you means it is not possible. Means this if you place a point here, then then you means it you here you will means if you place a point here, then you cannot place another point within this. So at most, you see, at most 6 points will be there. That means why I am saying this, our objective is to say that I don't need to compute the distance of this point P, with all the points that lie within the right side strip. No, I need to compute the distance of this point with only with this set of points, and at most 6 points. Okay. Or suppose if you are not agree with me, you can take 8 points. Not okay. 8 points. Fine, no problem. But constant. Okay. Now I need to compute the distance of this point with the 8 points or 6 point lying within this rectangular region R. So now whenever I will go from this to another point, means you see, for this I will consider the points that lie within this zone. I will consider the points that lie within this zone. At most 8 points, fine. Now again, after this, I will go to the next point here, suppose, and at that in that case, I I will compute the rectangular window. I will compute the rectangle with respect to this, with respect to this, and I will compute the distance of this point with all the points that lie within this zone. So that means I will, when I am going from this point to this point, the right side rectangular window also increases, means shifts towards upwards. Fine. That means I will start from the bottom of the P1 zone, and I will see which points means if I have the points in the increasing order sorted, then I will just what will happen? I am here in this case, and I have a window like this. Next, I am going to here, suppose, then I have a window like this. Next, I am going to here, then my window will go like this, and in this way I will compute. So if there are linear number of points in this side that you are saying n by 2 or whatever it may be, clear almost, so I need to compute, I need 8 comparisons or 6 comparisons per point. So 8 into 6 sorry 8 into n, 8 n comparisons. So that means I need linear number of comparisons. Big O of n comparisons are required. Fine. So, but please remember, I can do this only if the points are pre-sorted. Means before starting the algorithm, the points are already sorted. Already sorted. So that means before starting the algorithm, please remember you sort all the points with respect to x-axis for finding out the median, with respect to y-axis for moving the points, means considering the points in the increasing order. So that takes big O of n log n. But you please remember, I need to sort the points only once, not twice. Clear? So I have the sorted list of points with respect to x coordinate, with respect to y coordinates. Please remember, I will do this sorting only once, not twice. Then what I am doing, I am dividing the point set into two parts, left, right, after computing the median, and then I will find out the closest pair for the left half S1, right part S2. Then which is the minimum delta 1, delta 2, I will find out, and I will consider a strip. And after computing that strips, I will consider the points in the left part, suppose, in the increasing value of y coordinates, which lies within those I can find out in linear time, and I will move one by one, that the y coordinates increases. And similarly, the rectangular window that lie at the right side will also increase on a shift toward upwards. So entire time needs big O of n time. So this processing needs big O of n time, and 2tn by 2 is the for means for the left part, and right part Tn by 2, Tn by 2, and this is for finding out the uh, comparing the distance between the left part and right part, means P1 P2 within this. So entirely this will be big O of n log n. Clear? So I stop here and I will upload, and if you have any problem you may ask me in the next class, because you have now classes, I think. You may leave it now. Okay?
Okay, sir. And sir, will you be uploading